Now in this class, you'll see dimensions of the flywheel rim, turning moment and flywheel. It is in mechanical engineering. So let us see the dimensions of the flywheel rim. We know that a flywheel is a device which absorbs energy when there is excess of energy and which gives out its energy when there is a requirement of energy. Excess of energy occurs during power stroke or expansion stroke or working stroke. There is a requirement of energy during other strokes such as suction stroke, compression stroke and exhaust strokes. So the flywheel absorbs energy. Therefore, flywheel has certain mass. Because of its inertia, it absorbs energy and it gives out its energy. So here, in this process, let us see here, let us take this is the flywheel rim of the flywheel. T is the thickness of the flywheel rim and B is the width of the flywheel rim. It is not shown here. It is perpendicular to the plane of the board. Width of the flywheel rim. This is the thickness of the flywheel rim. R is the mean radius of the flywheel rim. The flywheel rotates at a mean speed of n RPM, n revolutions per minute. V is the tangential velocity V at any point here on the mean radius. R is the mean radius of the flywheel rim because T is the thickness of the flywheel rim. So R is the mean radius of the flywheel rim. V is the tangential velocity of the flywheel rim. So here D is the mean diameter of the flywheel rim in meters. Let D, capital D is equal to mean diameter of the flywheel rim. Therefore R equal to mean radius of the flywheel rim. R is equal to D divided by 2. Diameter divided by 2. Rho is equal to, this is rho, equal to density of the rim material. The flywheel rim is made up of mostly made up of cast iron or alloy steel, etc. Rho is the density of the flywheel material. Rho is the density of the flywheel material, that is rim material. It is in kilogram per meter cube. Density is in kilogram per meter cube. N is the speed of the flywheel rim, mean speed of the flywheel. Omega equal to angular velocity of the flywheel in radians per second. Omega equal to 2 pi n by 60, we know that. Right. Then V is equal to linear velocity. How to calculate the linear velocity V? Here V is equal to pi d n by 60. Pi d n by 60. Pi into diameter of the flywheel rim into RPM divided by 60. How? Because V is equal to R omega. We know the formula. R is the radius of the flywheel rim. R is diameter divided by 2. So V is equal to, velocity is equal to R omega. Diameter, R is diameter by 2 into omega is 2 pi n by 60. 2 cancels. This becomes V is equal to pi d n by 60. Therefore, this is the linear velocity of the flywheel rim. Now, the flywheel here, the flywheel rotates at n RPM, it rotates. Therefore, the rim material is subjected to centrifugal stress. Centrifugal, because of the rotation, the rim material is subjected to centrifugal stress. It is otherwise called tensile stress or hoop stress, H-O-O-P, hoop stress or tensile stress or centrifugal stress. Let sigma is equal to centrifugal stress induced in the flywheel. Sigma equal to centrifugal stress or tensile stress or hoop stress. It is in Newton per meter square. Now, let M is equal to M equal to mass of the flywheel rim. Mass is equal to, we know that formula, mass is equal to density into volume. We know that mass is equal to density into volume. This is the general formula. So mass m is equal to density rho. Density is the density of the material of the flywheel rim. It is rho, already we have given. Rho into volume is pi d into A. Pi d is circumference. Pi d into A is cross-sectional area of the flywheel rim. A is equal to, this is the formula actually, mass of the flywheel rim is equal to pi dA. A is equal to cross-sectional area of the rim. Where A is the cross-sectional area of the rim, so mass equal to density into volume. This is density, volume is pi d into A. A is equal to B into T, where B is equal to, B is the width of the flywheel rim, width of the rim. T is equal to thickness of the rim. T is equal to thickness of the flywheel. This is the thickness of the flywheel rim. Right? T is equal to thickness of the flywheel rim. B is equal to width of the flywheel rim. Therefore, cross-sectional area A is equal to B into T. That is width into thickness. Therefore, mass of the flywheel rim M is equal to density into pi into D into A. Density into volume. Density is rho. Pi dA is the volume of the flywheel rim. Now we have to find. So we know that tensile stress or hoop stress is sigma. Sigma is equal to rho into V square. This is the formula. You have to apply this formula. Use this formula. Sigma centrifugal stress or hoop stress is equal to rho into V square. Therefore, V is the linear velocity of the flywheel rim. V is the velocity of the flywheel rim. Therefore, V is from this we can write V square is equal to sigma divided by rho. Therefore, V is equal to square root of sigma by rho. So this is the linear velocity of the flywheel rim. V is equal to square root of rho. Square root of sigma divided by rho. Sigma is the hoop stress. Square root of hoop stress or centrifugal stress divided by density of the flywheel material. Therefore, mass of the flywheel M is equal to density rho into pi d into A. This is the formula. Where A is equal to B into T. A is equal to B into T. This is the formula. This is how we have to find the mass of the flywheel rim. Right? While using in the problem. Okay. Right. That's all about the dimensions of the flywheel rim.